Welcome to this explainer. Today, we are diving into something absolutely mind-bending. We're going to take a really fascinating journey that starts all the way down at the microscopic physical flaws of your computer hardware, and we're going to travel all the way up to perfect algebraic geometric lock-in within decentralized finance. We are talking about ditching the messy, probabilistic approximations our computers make every single day in order to achieve absolute, mathematically exact digital truth.
Now, you might be thinking your computer is this flawless machine of pure logic, right? Well, let's shatter that illusion real quick. Researchers call it the grand computational illusion. We tend to assume our machines understand us and deal in exact logic. But the reality, the machine doesn't understand your intent at all. Beneath the surface, 80 to 90% of modern heavy compute cycles are actually just hardware-level approximations. They are literally just highly educated guesses burned right into the silicon itself.
So here's our roadmap for today. We'll cover the grand computational illusion, the Cartesian AMM trap, the lens polar shift, Pell-Smith integer rings, and finally, achieving geometric lock-in. Let's get right into it.
Section 1. The grand computational illusion, or what happens when your computer just guesses.
Think of your computer's floating point unit, or FPU, as a gambler. Because it uses secret seed tables to guess its way through complex math, it suffers heavily from what we call vanishing point probabilities. It's actually a lot like the famous 23-person birthday paradox. You know the one, right? Where it only takes a remarkably tiny sample size before the probability of a mathematical collision or a critical error crosses that 50% threshold of useful work. But on the flip side, you have the arithmetic logic unit, the Surveyor. It deals purely in deterministic truth. For the Surveyor, 1 plus 1 is 2, period. No guessing involved.
Relying on that FPU Gambler creates what's known as the wood chipper effect. Because the math is essentially just guessing, it permanently destroys the exact provenance of our original data. It functions like a giant data blender. In information theory, this is exactly what happens with Shannon's rate distortion. You compress and guess, and you can never ever reverse engineer the smoothie back into its exact original fruit. You are permanently left with this untraceable, continuous margin of error.
Moving on to Section 2, the Cartesian AMM trap. This is where we see hardware flaws bleeding directly into decentralized finance.
Early decentralized exchange architectures actually fell right into this trap while trying to optimize capital efficiency. Models like Uniswap v3 use Cartesian frameworks. Imagine trying to draw a perfect, smooth circle using only square Minecraft blocks. You literally can't do it perfectly. You're forced to segment those smooth, continuous curves into discrete, lossy approximations. And that numerical drift creates a tiny gap. It's a vulnerability that directly opens the door for exploits like sandwich attacks and dust grinding.
When you try to capture a smooth curve using those blocky Cartesian Riemann rectangles, you're basically just guessing at the true body of the data. The grid framework always leaves a margin of error on the table. But contrast that with a polar tick model, which maps data seamlessly. The circle captures it perfectly, without the blocky guesswork.
Which brings us to Section 3, the lens polar shift, concentrating liquidity omnidirectionally. This is a real game changer. Think of a physical lens, like a gradient index lens that bends light waves omnidirectionally toward a single intense focal point. Well, the concentrated circular market maker does the exact same thing, but with capital. Lens concentrates liquidity omnidirectionally along a non-Euclidean circular manifold. It completely abandons the clunky grid in favor of the perfect circle.
But wait, we hit a massive technical wall here. To move along a circle, you fundamentally need trigonometry, right? But the Ethereum virtual machine, the EVM, natively cannot calculate floating point trigonometry like sine or cosine. And if we try to approximate it, we fall right back into the hands of the guessing FPU Gambler. So the big question is, how do we traverse this circle flawlessly?
And that leads us to Section 4, Pell-Smith integer rings, where ancient math steps in to solve modern computing.
So how does Lens solve the EVM's trigonometry problem? It uses Pell's equation. This is what's known as a Diophantine equation. Basically, it's a strict mathematical rule that demands pure, exact whole numbers. No decimals allowed. By forcing the math strictly into the realm of exact integers, our absolute deterministic surveyor takes over, and we completely bypass the guessing gambler. It is pretty much a magic trick for computing.
Instead of using some sloppy rounded decimal for an irrational number like the square root of 2, Lens generates exact integer sequences. Using Pell-Smith AN sequences, it calculates ratios of exact Pell-Lucas integers to get increasingly accurate coordinates. It bypasses Shannon's rate distortion entirely and achieves absolutely incredible precision without ever letting the hardware make a single guess.
This is quite literally on-chain magic. By using Chebyshev polynomials, the system creates a perfect translation layer. It takes messy, infinite trigonometry and turns it directly into division-free integer arithmetic. There's no division, no square roots, no guessing. Just pure algebra turning abstract angles into exact rational coordinates on the circle.
Finally, Section 5, Achieving Geometric Lock-in, Absolute Digital Truth.
So, how does this hold up under the pressure of millions of high-frequency trades? Lens uses something called Leonardo dynamics. When a swap pushes the system incredibly close to a boundary, it doesn't drift off into some compounding rounding error. Instead, the dynamical system undergoes a phase transition. Driven by those exact Pell-Smith AN sequences we just talked about, the chaotic path literally collapses and anchors itself into a stable period 2 attractor. It creates an exact, mathematically stable geometric lock-in.
And you know what? This scales brilliantly. By applying the Smith normal form, Lens takes massive, dizzyingly complex multi-asset pools and essentially untangles them. It separates mind-bending n-dimensional complexity into independent, perfectly straight 2D Pell curves. This means you can have unlimited assets, all executing seamlessly at a flat, totally predictable O1 gas cost.
By merging these non-Euclidean circles with exact integer rings, Lens kicks out those vulnerable division and square root operations entirely, replacing them with simple Brahmagupta group products. Ultimately, it takes that untraceable continuous margin of error and replaces it entirely with a defined cork. It stops the data leak completely cold, achieving deterministic execution and the absolute holy grail of numerical precision on-chain.
We started with the messy, guessing FPU Gambler down at the microscopic silicon level, and we've traveled all the way to an exact, mathematically locked-in substrate for global finance. It leaves us with a truly profound question to think about. Now that we've bridged pure mathematical logic with real-world, error-free execution, literally tricking rocks into thinking with lightning, what will you build next on this absolute substrate? Thank you so much for joining me for this explainer. Keep learning, keep exploring, and I'll catch you next time.